Moving forward, our fourth presenter, Vidar Strand, is a business development officer at Neodrill, and he will be talking about CAN, faster, cheaper, safer, and environmentally friendly. Vidar, the floor is yours.
Thank you, Winnie. So, yeah, I'm going to talk to how our products, basically the CAN-ductor and the CAN-integrator, could really hit these marks. So, first of all, the CAN is technology being developed by a drilling engineer that was out drilling and realized there were some challenges in terms of top hole developments. And he came up with this idea of rather than using the rig for drilling and typically cementing a conductor in place, we have developed a solution where we deploy the surface well or the wellhead in a CAN. That will sort of reduce the rig time and then obviously then also reduce the cost. And we see a clear reduction in risk, and I'll talk more about that, and a huge upside there in emissions. And talking about development wells or CO2 injection wells, which is very popular these days, we also see a reduced time to the first production or injection. I will start with a video from a project that we are sort of recently delivered and sort of continuing delivering on in the North Sea here in the UK sector. Shows the process we would typically go through for this was a development well where we would get the CPT data from the ground, and we would do the geomechanics to design and set the size of the CAN. These CANs are typically delivered, or as a standard, delivered with 6 meter in diameters, and then we adjust the length to accommodate the soil conditions that we are being fed the data from. We are set up to do this manufacturing locally here in Stavanger, Norway, but essentially we could do this anywhere in the world where we have to find the qualified facilities. Currently we're doing one project down in Romania for a later installation in the Black Sea as a reference. We've also been down in Australia doing the same. So here's from the SIT on the ground where we integrate the subsea production system on top of the CANs. Here's a troll deflector and the wellhead being put in place and cemented into the center pipe. From there, we do all these kind of tests to make sure that the equipment is fit for installation, and then we preferably install these in an upright position from a construction vessel like this, but we have also done this from anchor handlers in a vertical position. So here's that location, and we are ready to deploying and lift it overside and lift it down on a heave compensator crane, lower it down, and we penetrate it into the formation until we sort of hit resistance. We adjust the inclination, and then we connect the ROV pumps, and we evacuate the water inside. First of all, we close the hatch, the evacuation port for the water to and the air to spill out before we activate the suction. And not typically we will come in at less than 0.3 of a degree from the vertical on these CANs in average. Once this is in place, we will do a survey to make sure everything is left as it should be, and the troll structure being closed over if that's part of the project. On this one there is no, other than the troll deflector that you see the bottom. And then the few tools that we need will be pulled back to surface and ROV recovered and jobs done. So very quickly on the basis of the CAN. So you saw the manufacturing. It's really a suction anchor with a centerpiece sitting in the middle, and inside there we integrate the the low pressure wellhead with a standard extension, and we cement it in place. So it's a known sort of barrier that you would typically see for these kind of installations, and then lower it in and installed, as you can see on the video. So we typically turn these around. So we have a pool of these, so we can do for exploration typically, where we can turn around 4 to 8 weeks. And we have to extend or shorten the skirts. We have to do the analysis for sea fastening these and all that stuff that you saw on the video. Should we, in some cases, manufacture new ones? Typically for production wells, we foresee around 18 weeks, depending on the market, of course, and the capacity as we see on our sub-suppliers. And we also offer bundling campaigns where typically we have one customer having one can and another one other. So instead of these having each boat, we sort of bring them together and we hire one boat on a campaign, reducing the overall cost for the customers. And so fast turnaround, but also the essence here is, of course, that we remove 2 to 4 rig days from the top hole drilling, depending on the formation we drill in, of course, but also the water depth. So in all, if we look at an exploration well, which is this, we see that there are savings, and these are savings that the customer evaluate. But I think the non-tangibles, the other things that we're going to talk more about around the risks associated with it, the reduced risk around the wobbling wells and wells out of inclination, and the HSSC sides of it that I'm going to talk to are just as important to the savings. More on the development wells, we clearly see that is maybe where the big savings are. So here's a couple of examples. These are Norwegian sector examples, where a single slaughter with 4 suction cans, where we could have brought this into a third, really, in both in size and also in cost from our regular development. So obviously, just looking at it, I think we all can see the saving and the upside that there here would be for the developments. So this is actually a low case of the savings that we can see. So savings both in steel, manufacturing, and the drilling cost. Risks, I think that's very, very important. Here's from a conductor running, typical conductor running. These are 30-inch conductors. These days, very often 36-inch are being dealt with. Even heavier, even more difficult to handle, requiring bigger tongues and so on. And this is really, you wouldn't like to see that. If you can avoid it, you would like to not have all these big, heavy chunks being lifted into the red zone where people are operating. Yeah, things are getting more automated, but still you would have most likely people in there to do it on these kind of sizes. So that's the risk of EHS, in addition to the operational risks that I just talked about. Making sure that you have a solid foundation, a foundation that is engineered, and that you're sure that once you get in place with the BOP, you know that it's designed to take the load. While you're putting in there to the soft soil, you can never really be 100% sure that that's going to be taking the loads from the BOP. You may have done your fatigue analysis and all that stuff, but I can tell you, it doesn't get a good feeling when your valves start wobbling when you put your BOP on. Environmentally, we also see there's a huge benefits, and this is results from a study we did for one customer. The customer had 2 very similar wells, and one was drilled with a semi, the other was done with a CAN-ductor. And a third party concluded that we saved around between 400 and 600 metric ton of CO2 by doing that way. In addition comes all the savings that we have from the mud, so no mud required. Sometimes you don't need it, but sometimes you do. And there's no cement to cement the conductor in place. And remember, when you cement the conductor, you normally do maybe 200 and even 300% excess that you just spill out on the seabed. And all this counts up, of course. And And then another thing that I think is very positive, and on this one compared to a regular conductor, you would, from a regular conductor, once you're doing the end of life P&A, you would maybe get 10 to 20% of your conductor string back. With this solution, you will have 100% of it being returned. So today we have done 46 installations, and you can see the different customer that has tried the technology. We have installed for exploration and production. We see an increased uptick, the market understanding the potential here, not only the cost savings, but all the additional savings that this really gives. And we're now seeing a sort of a tendering or a sort of tipping point where it's becoming more production wells rather than exploration wells that's being done with this solution. And we have installed in all kind of formations. Either it's a mixed clay or sand, or sand or clay. So, yeah, there are a few limitations, and these limitations are, of course, at the hard side and the very, very soft sides. But these are things that we can look at. So if you have CPT data, we would be more than willing and happy to look into this if a CAN-ductor or a CAN-integrator for developments would be feasible for your project. And as I say, please don't hesitate to reach out. A lot of opportunities out there for developers to take the benefits and advantages of the CAN-integrator going forward. And we're working with both oil companies, but also SBS suppliers to find good solutions to integrate the SBS system here to minimize cost, time, emissions, as I mentioned. Thank you so much for listening. Hope to hear from you soon.